Offshore construction and platform installation showcase advanced engineering, demanding precision, innovation, and resilience to deliver vital marine energy infrastructure globally. Battelle delivers safe, sustainable environmental solutions for oil and gas. U.S. Pump Corp provides advanced pump system solutions delivering reliable, efficient, and customized pumping technologies for industrial and commercial applications. Their expertise ensures optimal performance, reduced downtime, and innovative solutions tailored to meet diverse fluid handling needs. PROM is a recognized world leader in the design and manufacture of portable machining equipment, delivering solutions tailored to your unique needs. Engineering world-class machines, PROM offers a comprehensive range of equipment including tube and pipe bevelers, orbital tube cutting and beveling machines, split frames, tube squaring machines, pipe-facing machines, high-speed cutting and beveling benches, as well as flange and valve-facing machines. Specialized solutions are also available for the construction, maintenance, and dismantling of nuclear power plants, helping extend the life and enhance the performance of critical components. PROM machines are built to operate in extreme conditions, including hazardous areas, subsea environments, ionized radiation zones, and other demanding settings. Suitable for virtually all materials: stainless steel, mild and alloy steels, duplex, super duplex, inconel, and exotic alloys. PROM equipment can handle any project, from cutting, beveling, facing, and counterboring to coating removal, squaring, and pipeline construction and repair. Serving major industries worldwide, including power generation, oil and gas, shipbuilding, tube processing, high-purity applications, aerospace, and defense, PROM has earned a global reputation for versatile, durable, high-precision machines. Trusted for their performance and reliability even in harsh environments, PROM's innovative solutions reflect decades of technical expertise and commitment to excellence. The Panama Canal expansion has reached a major milestone with the installation of the new lock gates on the Atlantic side. These massive steel gates, each 10 meters wide, 30.19 meters high, and weighing 285 tons, are transported using self-propelled motorized wheel transporters featuring over 400 wheels. This complex operation ensures precise placement of the gates, which will control water flow in the canal. In total, the expanded locks will feature 16 rolling gates, with 8 on the Pacific side and 8 on the Atlantic, enhancing global shipping capacity. The installation of the jacket and topside structures is a critical phase in offshore platform construction, involving a combination of precise marine operations and heavy lifting techniques. Initially, all materials and structural components are transported to the offshore site using a material barge. The barge carries the jacket, topside modules, and necessary braces, approaching the installation area alongside a crane barge, specially equipped for lifting these massive structures. The process begins with the brace monopod pile installation. The brace monopods are positioned accurately above their designated locations, using positioning guides and dynamic positioning systems of the crane barge. Once aligned, the piles are carefully driven into the seabed to ensure structural stability. These piles serve as the foundation for the monopod jacket, providing both support and resistance against environmental forces such as wind, waves, and current. Following the pile installation, the brace monopod jacket is prepared for lifting. Using the crane barge, the jacket is connected to heavy lift slings, and the upending process is initiated. Upending transforms the jacket from a horizontal transport orientation to a vertical position ready for installation. This operation requires careful control of the center of gravity and dynamic movements to prevent any swinging or damage during the lift. Once in a vertical orientation, the jacket is gradually lowered down onto the pre-installed monopod piles. Precision during this lowering phase is crucial, as the jacket must fit exactly over the piles to ensure proper load transfer and alignment. Any misalignment can compromise the structural integrity of the platform and require time-consuming adjustments. After successfully securing the jacket to the monopod piles, attention shifts to the topside installation. The topside modules, which house equipment, living quarters, and operational systems, are transported via the material barge and positioned over the jacket using the crane barge. They are carefully lowered and connected to the jacket, completing the main structural assembly. Finally, boat landing installation and additional piling on both sides of the platform are executed. 2 piles on each side are installed to provide added support for boat landings, ensuring safe access for personnel and materials to the platform. These secondary piles enhance stability and facilitate operational logistics around the installed platform. The combined execution of pile driving, jacket upending, lowering, and topside placement demonstrates the complexity and precision required for offshore construction. Each step relies on careful planning, skilled operators, and specialized marine equipment to ensure a safe and successful installation of the jacket and topside structures. The transport and installation of the Aasta Hansteen spar topside began in South Korea, where the 24 300-ton topside was carefully prepared for shipment. The heavy lift vessel, White Marlin, was ready to receive the structure. Using 4 skid tracks and dozens of strong wires, the topside was gradually pulled onto the deck, ensuring precise alignment and safety throughout the operation. Once fully secured, the White Marlin set sail for Norway, navigating thousands of kilometers across open seas. Upon arrival in the Norwegian fjord, the vessel was positioned between 2 smaller S-class support vessels. The topside was then transferred onto a specially designed catamaran barge, forming a stable platform for the floatover installation. The catamaran barge sailed to the designated mating location in the fjord, where the topside was carefully aligned above the substructure. The floatover installation commenced with the tip of the substructure remaining above the waterline. By ballasting down the barge while deballasting the substructure, the topside was gradually lowered into place. The mating operation proceeded with precision until completion, successfully securing the topside atop the spar substructure. The export cable pull at the Burbo Bank offshore wind farm extension demonstrates a highly coordinated marine operation. Heavy plant and specialized equipment were mobilized to handle the cable efficiently. The Haven Sea Jack, equipped with a 10-ton tensioner, played a critical role in controlling the bite in the cable during the pull-in. Meanwhile, the Jan de Nul cable-laying vessel, Willem de Vlaming, was strategically positioned 1 kilometer offshore to deliver the 24.3 kilometers of cable from the TJB to the OSS. To bring the cable ashore across a 350-meter tidal area, 758 pillow floats were deployed, ensuring safe and precise alignment. A 760-meter-long horizontal directional drill, installed in April 2015, facilitated the transition from sea to land. Divers were tasked with carefully removing the floats once the cable was correctly positioned. The entire operation required meticulous planning and teamwork, yet the pull-in was completed efficiently within 18 hours. Throughout the process, the tensioner maintained cable stability, and the combined use of advanced vessels and offshore equipment ensured minimal environmental impact. This operation highlights the complexity and precision involved in extending offshore wind infrastructure. The installation of the Tienong BK-TNG platform in Block 04.3 of the Nam Khan Sun Basin showcases a major offshore heavy-lift operation carried out with the shear-leg crane vessel Asian Hercules 3. After arriving in the field, the vessel prepared for the critical lift as the 200-ton BK-TNG Topside was transported to the site. Once the Topside reached the installation location, Asian Hercules 3 executed a precise heavy lift, hoisting the massive structure and carefully positioning it onto the pre-installed jacket. This operation required strict coordination, accurate load control, and continuous monitoring to ensure stability in offshore conditions. Following the successful placement of the main topside, the team proceeded with installing the 850-ton living quarters module. The shear leg crane again performed a controlled lift, aligning the accommodation block onto the topside with exact tolerances. Together, these operations marked a key milestone in completing the Tienong platform, demonstrating advanced offshore engineering and the capabilities of Asian Hercules 3 in complex heavy lift missions. The Subsea cable installation campaign involved laying two sections of 800-meter, 3.5-inch diameter power cables from the offshore platform to the power barge. The operation was supported by a dedicated marine spread, led by the AHTSDP-2 vessel Limon Offshore, which provided precise station keeping throughout the work window. Prior to deployment, the crew completed all preparatory stages, including cable inspection, equipment alignment, and pre-dive checks to ensure full operational readiness. Air diving services supplied by Pacha Dynamica allowed divers to conduct detailed subsea tasks, such as guiding the cable through the J-tube, securing clamps, and verifying touchdown positions. The cable-laying tensioner and associated equipment from Bukaka ensured controlled payout, maintaining the required tension to prevent overstressing the cable during lowering. At the same time, Explora Prima conducted continuous positioning surveys, enabling accurate route control and safe seabed placement. Safety remained the top priority, with the team executing every step under strict procedures. The DP2 vessel Catherine Queen later joined the spread as the operation progressed toward Tirta Macmore from PHE-30. Thanks to coordinated teamwork and stable weather conditions, the project was successfully completed in 10 days ahead of the 14-day target schedule. The crane barge IZU, operated by Fukada Salvage and Construction, is a prominent heavy-lift vessel designed to support complex marine engineering operations throughout Japan. Measuring 63 meters in length and 26.4 meters in width, this powerful barge is engineered for stability, precision, and safety in demanding offshore conditions. With a maximum lifting capacity of 700 tons, IZU is capable of handling large structures such as bridge components, caissons, offshore modules, and salvage equipment. Flying the Japanese flag, the vessel represents the advanced maritime technology and operational expertise of Japan's heavy lift industry. In November 2017, IZU was recorded sailing westward through the Kanmon Straits, one of Japan's busiest and most strategically important waterways. This narrow channel, separating Honshu and Kyushu, requires careful navigation due to strong tidal currents and dense traffic of commercial ships. The barge was under tow by the tugboat Shojin Maru, which provided the maneuvering power necessary to guide the non-propelled crane vessel safely through the strait. Their coordinated movement demonstrated the high degree of seamanship and communication essential for operating large maritime construction assets in confined waters. The video captures IZU's distinctive silhouette with its towering crane structure rising above the deck. This heavy lift crane is the core of the vessel's capabilities, allowing precision lifting during harbor construction, underwater recovery assignments, and offshore installation projects. As IZU progresses steadily through the strait, it reflects the broader activities of Fukuda Salvage, a company well known for its contributions to Japan's marine infrastructure, emergency response operations, and coastal development. Overall, the passage of the crane barge IZU through the Kanmon Straits highlights both its engineering strength and operational versatility. Whether engaged in lifting, salvage, or transport support, IZU remains an essential asset for large-scale marine construction works across Japan's waterways. The Swordfish offshore trencher represents a new level of versatility in subsea cable burial, capable of cutting trenches up to 53 meters deep across diverse seabeds. Designed for the growing demands of renewable energy, this high-powered, custom-built vehicle supports deep-water operations and strengthens global grid interconnections. The umbilical installation project begins with the offshore team preparing the well connection area and confirming communication among all units involved. As the vessel approaches the designated field, operators verify equipment status, check the rollers, and ensure that the handling frame is correctly aligned. Continuous radio communication between deck crews, ROV pilots, and the STP control room ensures that each step is synchronized before the pull-in operations begin. Once the umbilical head reaches the working deck, technicians secure it and conduct a final inspection. They confirm the condition of the ferrule and lifting interfaces, allowing the rigging team to position the lifting gear. The message exchange heard in the operation reflects real-time coordination. Supervisors authorize the lift, operators confirm readiness, and the umbilical head is carefully transferred to the ramp zone. After this, the crew prepares to lower the line to the seabed, making sure no change in configuration compromises tension or curvature limits. The ROV provides visual monitoring throughout the deployment, guiding the descent and ensuring the umbilical remains within the planned route. Deck operators adjust the tensioner settings, while the control room updates progress markers and confirms every phase through internal communication. As the umbilical moves through the rollers and passes reference points, the team validates depth readings and position signals to guarantee safe advancement. With the main section deployed, the next phase focuses on connecting the umbilical to the subsea well system. The vessel holds position while the ROV maneuvers the umbilical end toward the subsea structure. Operators observe alignment carefully, adjusting angles to prevent interference. The ROV then positions the termination head into the receptacle, completing the mechanical engagement. Clamps and securing pins are installed according to procedure, finalizing structural fixation. Once the mechanical connection is confirmed, the ROV inspects the entire setup, verifying that no debris, misalignment, or tension irregularities is present. Communication exchanges celebrate that the critical step has been completed successfully, and the team proceeds to check the electrical and hydraulic continuity of the umbilical. These verifications ensure the control, power, and chemical injection lines are fully functional. At the end of the operation, the offshore supervisor thanks the crew for their professionalism and highlights the importance of teamwork among all personnel on board. Smooth coordination between operators, controllers, and support teams ensures that the umbilical installation and well connection are completed safely, efficiently, and in full compliance with the project requirements. On July 13, 2020, the 1,000-foot bulk carrier, Presque Isle, struck the base of the North Pier of the Duluth Ship Canal shortly after 7 a.m., creating a dramatic scene captured on video. As the vessel approached the narrow canal, morning winds and a strong lateral current appeared to push its bow off the intended line. Despite corrective maneuvers from the bridge, the massive ship gradually drifted toward the pier. Moments later, its port side scraped against the concrete foundation, producing a loud impact and sending debris and spray into the air. The incident caused visible damage to the pier's edge, though the ship continued its transit through the canal at reduced speed. Coast Guard personnel and local authorities were promptly notified, and inspections were initiated to assess structural integrity. Fortunately, no injuries were reported, and there was no indication of significant hull breach or pollution. The Presque Isle, one of the largest vessels operating on the Great Lakes, requires precise navigation through the Duluth entry. This event highlighted the challenges faced by mariners when guiding such large ships through confined waterways, particularly under shifting environmental conditions. In Finland, berthing operations are carried out in some of the harshest winter conditions found anywhere in the maritime world, and the featured berth offers a clear example of how professionalism and robust infrastructure ensure safe port access even at -20°C. As the vessel approaches the harbor, the sea surface is already stiffened by a thick layer of drifting ice, pushed constantly by the wind and tidal movements. Despite the extreme cold, the fairway remains navigable thanks to regular ice-breaking support and well-maintained approach channels that guide ships safely toward the berth. As the crew lines up for the final approach, visibility is shaped by the winter landscape. Pale daylight, frozen mist, and snow-covered breakwaters that mark the port entrance. The berth itself is built to resist heavy ice loads, featuring reinforced fenders, heated bollards, and structures designed to remain operational throughout the Arctic winter. Moreover, the navigational aids along the channel, from leading lights to buoyage, are equipped with ice-resistant housings to ensure reliable guidance despite freezing conditions. Because maneuvering in icy water requires precise power control, the vessel proceeds at a steady, minimized speed, using its bow thrusters and main propulsion to counter both the drifting ice and the gusty wind typical of northern Finland. Tugboat standby is an additional safety measure, ready to assist if the ice pack tightens close to the hull or if the berth alignment needs correction. Communication between the ship's bridge and port control remains continuous, ensuring that real-time ice movements and wind data are shared to support a smooth berthing sequence. Once alongside, the ship settles against the fenders, with crew members stepping cautiously onto the frozen deck to secure mooring lines. The berth area is regularly cleared of snow, and heated pipelines are used to prevent equipment from freezing. Despite the challenging environment, the operation showcases the efficiency and resilience of Finnish port infrastructure. Ultimately, berthing at -20°C demonstrates not only the engineering strength of Arctic ports, but also the skill and discipline of the crews who navigate these waters, maintaining safe and reliable maritime operations throughout the winter season. Symphony of the Seas, featured impressively in the dry dock video, stands as one of the most remarkable engineering achievements in modern maritime history. From its launch in March 2018 until January 2022, it held the title of the world's largest cruise ship before being surpassed by its sister vessel, Wonder of the Seas. Belonging to Royal Caribbean International's renowned Oasis class, this giant cruise liner represents the pinnacle of luxury, innovation, and large-scale shipbuilding. Constructed at the prestigious Chantier de l'Atlantique shipyard in Saint-Nazaire, France, Symphony of the Seas first set sail in April 2018. With an extraordinary gross tonnage of 228,081 GT and a length of 361.8 meters, the vessel dominates the dry dock in the video, highlighting its massive hull, complex propulsion systems, and expansive superstructure. Its impressive dimensions allow it to accommodate up to 680 passengers, supported by a professional crew of 200 members, making it a floating city capable of delivering world-class service. The ship features 18 decks packed with amenities that redefine the cruising experience. Its two 759 cabins offer a diverse range of accommodations, from affordable interior rooms to luxurious multi-level suites overlooking the ocean. The onboard dining experience is equally exceptional, with 22 restaurants offering global cuisine, gourmet menus, and themed specialty venues. Guests can also enjoy 24 pools, whirlpools, and water play areas, providing entertainment for all ages. One of the most iconic features highlighted in the ship's layout is Central Park, a stunning open-air garden spanning 2 decks. Filled with real trees and thousands of plants, it offers a peaceful atmosphere surrounded by restaurants, cafes, and boutique shops. An impressive reminder of how much variety can be incorporated into a single vessel. In the dry dock, every detail of the ship is visible, from its massive stabilizers to the careful inspection of its hull plating and propulsion components. Dry dock operations ensure that a ship of this scale remains safe, efficient, and fully prepared for long voyages across the world's oceans. Overall, Symphony of the Seas continues to symbolize the ambition of modern cruise engineering, combining size, elegance, and advanced technology to offer unforgettable journeys on one of the greatest ships ever built.